I'm going to go through the review with you for our test over sections 2.3 and 2.4. The first half of the review is division, and the second half is complex numbers. The test will be formatted in a very similar fashion. Let's review some things about long division since that's our first concept. For long division, you're going to take the top and put that under your division bar, which is 24x squared minus x minus 8. It'll be important that you make sure that these terms go in order from greatest power to least and that there are not any missing. For example, if this was x to the third and then x, there would be a squared term missing and you would want to add in a 0x squared as a placeholder. In this one, that's not an issue. On the outside, I want to put my 3x minus 2. It's important for you to realize on this example that you could not do this with synthetic division, both because I've asked for it done with long division and because the divisor has 3x. To do synthetic, it would have to only have an x plus 2 or an x minus 2. Okay, the first question you should be asking yourself is how many times does 3x go into 24x squared? It goes in 8x times. If that's confusing for you, think 24x squared divided by 3x. 24 divide 3 is 8, and x squared divide x, one of those would cancel and you would get 8x. Just want to write that process out to the side just in case that's the part that's still troubling you. From there, we're going to distribute the 8x. 8x times 3x is 24x squared. 8x times negative 2 is negative 16x. Now I'm going to flip both of my signs and add. These two cancel, and I've got negative x plus 16x for a total of 15x minus 8. How many times does 3x go into 15x? It goes in 5 times. So 5 times 3x is 15x, and 5 times negative 2 is negative 10. Distribute. I'm going to flip my signs. My 15x's cancel, and I'm left with a remainder of 2. I know this is my remainder because 3x does not go into 2. My final answer on this problem would be x plus 5 plus 2 over 3x minus 2. Remember, remainder over divisor. Okay, let's look at the next problem. This is another long division problem. There's several more terms here, so I'm going to have to write a little bit smaller. I have x to the fourth minus 3x to the third plus 4x squared minus 6x plus 3. It's nice that the problem was given to me with the terms in order from greatest to least power, so that's nice. I have x squared plus, I have no x terms, so I'm going to put 0x plus 2 on the outside. I'm asking myself, how many times does x squared go into x to the fourth? It goes in x squared times. Now I distribute. X squared times x squared is x to the fourth. X squared times 0x is 0x to the third. X squared times 2 is 2x squared. I need to flip my signs. My first terms cancel as they always should. I have negative 3x cubed minus 0x cubed. So that's negative 3x cubed. 4x squared minus 2x squared, which is 2x squared. And I pull down the rest of my terms so I don't forget about them later. Now I'm asking myself, how many times does x squared go into negative 3x cubed? It goes in negative 3x times. Negative 3x times x squared is negative 3x cubed. Negative 3x times 0x is 0x squared. Negative 3x times 2 is negative 6x. Now I'm going to flip my signs. My first two terms cancel, and I'm left with 2x squared. Those cancel, so I've got plus 0x and plus 3. Now I'm asking myself, how many times does x squared go into 2x squared? And the answer is 2 times. So 2 times x squared is 2x squared. 2 times 0x is 0x, and 2 times 2 is 4. I flip my signs. The first ones cancel. The second ones cancel, and I'm left with negative 1. So my answer is x squared minus 3x plus 2, and then I've got minus or plus a negative 1 over x squared plus 2. If you wrote this as minus 1 over this, that would be the same answer, and I will count both correct tomorrow on your test. Let's look at the next section, which is synthetic division. Synthetic division is very convenient when I have a divisor of x minus a number or x plus a number. Remember that number is k, this one right here, and then I have to flip my sign. I'm starting with the top part, which my exponents go down by 1, so that's nice. 4, 3, 2, 1. And then there is no last term. Let me see if I can focus a little bit for you here. That might help. Okay, and I'm going to write my coefficients in order. So I have 6, negative 4, negative 27, 18, and 0. Again, I have the 0 because there is no number term. My k flips the sign, so I have 2 on the outside. And then I'm going to pull down my 6. Pull down the 6, and 6 times 2 is 12. 12 plus negative 4 is 8. 8 times 2 is 16. 16 plus negative 27 is negative 11. Negative 11 times 2 is negative 22. 18 plus negative 22 is negative 4. And negative 4 times 2 is negative 8. And 0 plus negative 8 is negative 8. Recall to write my answer, I'm going to start with this first term of 6, x, and I start with one exponent less than 4. So 6x to the third plus 8x squared minus 11x minus 4, and then a remainder of negative 8 over x minus 2. I could again write this as plus negative 8, and both of those answers would be sufficient. Let's look at the next problem. On this one, we should be noticing that our powers do not go in descending order. I go from 3 to 1 to 2 to 12, or to none, no power. So if I want to rearrange those so that they're in order, I'm going to have 3, then 20, then 29, then negative 12. My k value flips, so it is now negative 3, and now I just follow the process. Pull my 3 down, and 3 times negative 3 is negative 9. 20 and negative 9 make 11. 11 times negative 3 is negative 33. 29 and negative 33 make negative 4. Negative 4 times negative 3 is positive 12. And negative 12 plus 12 is 0. It's nice when my remainder works out that way. Not always the case, but it is here. Again, I'm going to start with the 3x, and power 1 less than the original would be squared. So I have 3x squared plus 11x minus 4. No remainder, so that's my full answer. The last thing about division is when we want to use synthetic division to find the values. Remember again that it's important for the powers to decrease by 1, and when we're finding f of a number, we do not flip the sign. This question asks for f of negative 3 and f of 1, so we'll have to follow this process through twice. The first time, let's start with 1, 10, negative 24, 20, and 44, my coefficients in order, and my first k value is negative 3. As I walk through this process, double check that your numbers are coming out the same. I get negative 45 times 3, oh my, I'm going to need a calculator here, 90, 135. So I've got 135 and 20, which is 155. 155 times negative 3 is negative, let's see, don't have my calculator handy, I apologize. Just doing this off to the side right now by hand, is negative 465. And so when I add those two together, I get negative 421. And so the answer to what is f of negative 3 is negative 421. And that's my final answer. I don't write it in the same form as above because I just want the remainder as my value. Let's do the same problem, so 1, 10, negative 24, 20, and 44 with the value of 1. Pull down the 1. 1 times 1 is 1. Add those, and that's 11. 11 times 1 is 11, so I've got negative 13. Negative 13 times 1 is negative 13. let's see, that would be 7 times 1 is 7. And my final answer is 51. So f of 1 is 51. That's it for the side with division. Let's flip over and look at things relating to complex numbers now. The instructions are to write the number in standard form. Some things you'll want to remember are that square root of negative 1 is I, and that I squared is equal to negative 1. That will be very important here. For number 6, we're going to leave the 3 alone, leave the negative, and then I want to take out the negative under the square root. So I'm going to say I square root of 25, and then my 3 can stay minus the square root of 25 is 5, and I have I left over. So I have 3 minus 5I, and I'm done because that's in standard form, A plus BI. The next one, I've got negative 5I, which can stay, nothing I can do with that one, and I squared, which is negative 1. This answer is not in standard form, so I want to rearrange it to say negative 1 minus 5I, and now it is in standard form, and I'm done. Number 8 is an addition problem, so I want to add my like terms. 7 and negative 4 makes 3. 5I and 2I make positive 7I. Again, that's in standard form, so I'm done. Watch out here. If I gave you one that was minus right here, you would want to distribute that negative sign, and if you didn't, it would be incorrect, so watch out there. Let's look at number 9. For number 9, I'm asking you to multiply. So to multiply, let's distribute the 5. 5 times 13 is, I'm sorry, I don't know that off the top of my head, 65, excuse me, so 65I, and 5I times negative 8 is negative 40I squared. So is that 65I? You know that negative 40I squared is like saying negative 40 times negative 1, so that's positive 40. And then in standard form, I have 40 plus 65I. Alright, let's look at the next one. I'm multiplying. I've got 10 minus 8I times 2 minus 3I. I want to distribute my 10, so I have 20 minus 30I. Distribute my negative 8, so I've got negative 16I plus 24I squared. I can combine my like terms here in the middle, so I have 20 minus 46I. And then I squared is negative 1. If I multiply negative 1 times 24, I've got negative 24. And in standard form, my answer would be negative 4 minus 46I. Remember, you don't want to leave I squared in your answer. Most recently, we learned how to divide things with complex or imaginary numbers in them. And we learned that you cannot leave I on the bottom. So to solve things like number 11 and 12, I'm going to use the complex conjugate, which is 4 plus I over 4 plus I. Remember, I take the bottom and switch the sign, and then duplicate, so I'm just multiplying by 1. I'm going to FOIL all of that out. At this point, I'm taking for granted that you should know how to FOIL, so I'm just going to walk through this very quickly. YouTube only allows me so much time to record these videos, and you're probably getting sick of hearing me. So I've got 24, add my like terms, plus 10I minus 1. And 16, the middle terms cancel as they always should. Minus a negative 1, which becomes plus 1. I've got 23 plus 10I over 17. And I divide the problem into its two parts. So I have 23 over 17 plus 10 over 17I. It's in standard form, so I'm done. Let's look at number 12. It is very similar to number 11. The complex conjugate would be 5 minus I over 5 minus I. If I begin to distribute, I've got 15 minus 3I plus 10I minus 2I squared over 25 minus 5I plus 5I minus I squared. The bottom middles will cancel. On the top, I've got 15 plus 7I plus 2, because the negative flips the sign, the I squared, and 25 plus 1. So we've got 17 plus 7I over 26, and my final answer is 17 over 26 plus 7 over 26I. Remember, on things like 11 and 12, if these were values that could reduce, you would reduce them. But I can't on this one, so I'm not worried about it. Finally, let's solve the last two problems using the quadratic formula. Remember to use the quadratic formula. You're going to start by labeling your values for A, in this case is 1, B is -2, and C is 10. From there, you want to plug it into the quadratic formula, which I will be giving you on your test. So I've got negative b plus or minus the square root of b squared minus 4ac all over 2a. When you have a negative number squared, that will become positive. Also, when you have a negative, that's positive. So I've got 2 plus or minus the square root of 4 minus 40 over 2, which is 2 plus or minus the square root of -36 over 2, which is 2 plus or minus I square root of 36 over 2, which is 2 plus or minus 6I over 2. And if I split that up, I've got 2 over 2 plus or minus 6 over 2I, which is 1 plus or minus 3I. I know I'm going through these quickly. I'm just running out of bandwidth here. Okay, last one, number 14. If A is 3 and B is missing, that means B is 0 and C is 1. Now I say B is missing because there is no x term here. And that's important that you know what to do with that. Okay, x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. -0 just falls away because there's no such thing. So I have plus or minus the square root of 0 squared goes away. I've got -4 times 3 times 1, which is -12 over 6. Some of you are going to be tempted to just divide that. That is not a legal move. Please don't. Now I've got plus or minus I square root of 12 over 6. Remember, at this juncture, you should be saying to yourself what perfect squares are inside of 12. So I've got plus or minus I, and the perfect square inside is 4, because 4 times 3 is 12, and 4 is a perfect square. The square root of 4 is 2, so I've got 2I square root of 3 over 6. And I can reduce that to plus or minus. The 2 over 6 reduces to 1/3, so I've got the square root of 3 over 3, and then the I goes on the outside. And that's my final answer. The test tomorrow, or the test on Thursday, should be very straightforward. Less problems, just so you're not overwhelmed. But you will need to work quickly, and it'll be over the long division and complex numbers. Good luck, and I hope the review has been a success for you.